Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with 4.1 exponential function part 2. In the previous video, I have explained there are three types of exponential graph. So the first one, we have the graph with the exponential growth. The second one, exponential decay. And the third one, we have the natural exponential graph. Now let's look at the transformation of exponential function. So basically all these transformation technique we have learned in the previous chapter, which is chapter 2. So the way how we apply this type of transformation technique is like what we have learned in chapter 2. So the first one, we have to apply horizontal shifting, and the last one will be vertical shifting, is either shift up and down. Between reflection and stretch or compress, so we can switch between these two. So first, let's look at the example for the horizontal shifting. So it's either shift to the left or shift to the right. For example, we have the function of fx is equivalent to 3 power of x plus 2. So if we have plus in the middle of the exponent, meaning that the graph will shift to the left. And for example of shift to the right, when we have, for example, 5 power of x minus 1, so it will be shift to the right by c unit. And then the next one, reflection. Example of the reflection on the y-axis, we have e power of negative x, where negative is on the exponent. And when it is reflect about the x-axis, so the example we have here, negative e power of x. So the negative is in front of the function. Then we move to the stretch or compress. So first we have to look at the vertical stretch or compress. If the factor is in front of the function, for example, we have 3 times with the 2 power of x. So when your c is greater than 1, so the transformation technique is stretch vertically by a factor of c. So for this case, for this example, stretch vertically by a factor of 3. And then when the c or the factor is between 0 until 1, for example, we have 1 over 4 power times with the 3 power of x. So the basic graph is 3 power of x, and since there is a factor in front of the function, so and the values of c or the values of factor is between 0 until 1, so the transformation technique is compressed vertically by a factor of c. So this is when the factor is in front of the function. When the factor is inside the function, for example, we have 3 power of 5x, so the factor is inside the function on the exponent. And another example, 2 power of 1 over 2 power of 1 over 3x. So when the c or the factor is greater than 0, the transformation technique is compressed horizontally by a factor of 1 over c. So in this case, our c is equivalent to 5. Therefore, the transformation technique is compressed horizontally by a factor of 1 over 5. And when the c between 0 until 1, for example, here we have 1 over 3. So the transformation technique is stretched horizontally by a factor of 1 over c. So 1 you divide by 1 over 3, so you will get bigger number, which is 3. So that's why the transformation technique is stretched horizontally by a factor of 1 over c. And the last one, when there is a vertical shifting, for example, 3 power of x plus 1, meaning that the graph will shift upward by c unit, and the graph will shift downward by c unit when you have minus. For example, 2 power of x minus 3. Now let's look at the example 1 here. Given the function fx is equivalent to 1 over 3 power of negative x minus 2 plus 1. So first we have to detect the transformation technique that we have here, and before that, of course, the basic graph or the basic function. So the basic function is y is equivalent to 1 over 3 power of x. So this is the basic function. And we have minus here, so the minus inside the function shows that there is a reflection about y-axis. So we can just write down in scratch here, and then we have -2 here, shows that the graph will shift to the right 2 unit, and we have plus, shows that the graph will moving up 1 unit. So now let's write down properly here. So we have here the first one. We have to sketch the basic graph, which is the function y is equivalent to 1/3 power of x. So this is the basic graph. And then the next transformation technique, if there is any movement left or right or horizontal shifting, we have to write down that one first. So the next step, the function will become y is equivalent to 1/3 power of x minus 2. So don't ever try to factorize the negative sign. You can just leave it as it is. In this case, we have negative x minus 2. Just leave it as negative x minus 2. So the transformation technique here is shift right 2 units. So if you already put the word right, you don't have to put the word horizontal anymore. So shift to the right is already understood that there is a horizontal shifting. And then the next one, the function will become y is equivalent to, we have a reflection here, so y is equivalent to 1/3 power of negative x minus 2. So the transformation technique involved here is reflect about y-axis. And the last one, we have the function is y is equivalent to 1/3 negative x minus 2. So the graph will shift upward by 1 unit. So we have here y is equivalent to 1/3 power of x negative x minus 2 plus 1. So let me erase this one. So the function here is 1/3 power of negative x minus 2 plus 1. So this is the transformation technique. So now from the basic graph, so you have to identify whether it will be exponential growth or exponential decay. So since the values of c is between 0 until 1, therefore we will start with the decreasing graph, or it will be exponential decay. So the graph will be like this. And then let's draw properly the graph. So the first graph refer to the first function, y is equivalent to 1/3 power of x. So we have here, so this is the axis, x and y axis, and this is the graph or the basic graph of the exponential decay. Okay, let me draw again. So this is our first graph. So with that 2 points, so since the instruction asks you to sketch with that, starting with the at least 2 points, so we choose the one of the point is on the y-intercept, which is 0, 1, and the next coordinate we can choose as 1, 1/3. So in general, the coordinate here should be 1a. So in general, it should be 1a. So since our a is equals to 1/3, so therefore we will put the coordinate here as 1, 1/3. Okay, the next one refer to the shift to the right. So please take note that originally we have the horizontal asymptote on the line y is equivalent to 0. Okay, the next one, so since the graph will shift to the right 2 units, so we will have something like this, x, y. So there is no changes on the horizontal asymptote because there is no changes on the values of y here. So HA, y is equivalent to 0. So the graph will be something like this. So with that new coordinate, so we have arrow here. So we have the new coordinate for the 0, 1. So 0, 1 will become 2, 1. So the changes is on the x coordinate, and the coordinate of 1, 1/3 will become 3, 1/3. And our horizontal asymptote, as you can see, still HA y is equivalent to 0 on the second function. And then on the next step, the transformation technique is reflect about y-axis. So when there is a reflect about y-axis, so from the left will be the graph. This is the y-axis. So left will be on the right, and the graph on the right will move to the left. So let us draw the graph. We have here the axis. This is x, this is y. So the new graph would be something like this. So the coordinate of 2, 1, so will become negative 2, 1, and the coordinate of 3, 1 over 3 will become negative 3, 1 over 3. So let us plot the coordinate here. So we have negative 3, 1 over 3, and the coordinate of 2, 1 will become negative 2, 1. So again, on the third graph here, the horizontal asymptote remain as y is equivalent to 0, because there is no changes on the y coordinate. So on this step, the changes is only on the x coordinate. And the last one, the graph refer to the shift upward 1 unit. So from the previous graph, so our graph will shift upward 1 unit. So since the changes in the y coordinate, so there will be the new horizontal asymptote, which is on the line y is equivalent to 1. So it is compulsory for you to draw the new horizontal asymptote, because there is a changes. Therefore, the new coordinate, the new graph will be something like this. So make sure you draw with the curve, and the graph is exponential decay. So in this case, since the graph is already reflected, so it shows that the graph will be on exponential growth. So the coordinate of negative 3, 1 over 3. So the coordinate of y you have to plus with 1. So the new coordinate will be negative 3, 4 over 3. The coordinate of negative 2, 1 will become negative 2 and 2. So this is the final graph. So the next step, the next question, they ask you to find out the domain and range. So when the question asks you to find out domain and range, it is referring to the final graph or the whole function. So we just have to focus on the final graph. So how to determine domain? So we have to look at the graph from the left to the right. So in general, the graph of exponential function itself have a domain from negative infinity until infinity. Therefore, the domain of this function is negative infinity until infinity. So how about the range? So originally, our graph have a horizontal asymptote on the line y is equivalent to 0. So on the original graph, the function have a domain 0 open until infinity. So since on the final function here, the graph is already moved up 1 unit. Therefore, looking at to this graph shows that the graph will start from 1 until infinity, and the values of y should be open. Therefore, the range is open bracket 1 until infinity. So I think that's all. So you can try out the rest of the example on the sketch the graph of exponential function by using transformation technique. Okay, thank you.